It's hard to believe, but off the Oregon coast, a massive underwater volcano is waking up. Axial Seamount, the most active in the Northeast Pacific, is stirring deep beneath the waves.
An underwater volcano in the Pacific Northwest is getting ready to erupt. It's called the Axial Seamount, located about 300 miles off the coast of Oregon.
It's hard to believe, but off the Oregon coast, nearly 1,000 meters underwater, a volcano is waking up in silence. Axial Seamount is the most active submarine volcano in the Northeast Pacific, a colossal undersea mountain that towers about 1,100 meters above the seafloor and sits roughly 1,400 meters under the ocean's surface. Axial lies along the Juan de Fuca Ridge, where tectonic plates split apart, allowing magma to rise. It is also fed by the Cobb hotspot, making it a hybrid volcano sitting at a junction of ridge and hotspot activity. The volcano has two major rift zones that extend north and south some 50 kilometers from the central caldera. The summit crater is a shallow, rectangular caldera with walls up to 150 meters deep in places. Lava flows, sheet flows, and vent systems are all part of its complex internal plumbing. Chapter 1: The Awakening Beneath the Pacific. It's hard to believe, but just 250 miles off the coast of Oregon, deep beneath the restless waves of the Pacific, one of the most active volcanoes in North America is stirring once again. Known as Axial Seamount, this underwater giant has erupted 3 times in the past 3 decades. And new satellite and sonar data suggest that another eruption may be closer than anyone expected. Axial Seamount isn't just any volcano. It rises from the Juan de Fuca Ridge, where 2 massive tectonic plates are pulling apart, tearing open Earth's crust and letting molten rocks surge from below. Over time, this relentless activity has built a mountain that towers nearly a mile above the seafloor. But what's happening inside it right now has scientists more concerned than ever. According to the latest readings from the Ocean Observatory's initiative, Axial is inflating rapidly. The seafloor is swelling upward by several inches each month, a clear sign that magma is accumulating beneath the crust. Pressure sensors installed at the site have begun detecting rhythmic pulses, like a heartbeat, rising from the magma chamber itself. In recent weeks, the number of micro-earthquakes near the summit has spiked to unprecedented levels, sometimes hundreds per day. These tiny tremors form a pattern eerily similar to what researchers recorded before its last major eruption in 2015, when lava burst across the seafloor for miles, reshaping the Pacific Ridge and sending shock waves across the ocean. And now, the same warning signs are back. Thermal cameras show new vents glowing faintly along the caldera floor, releasing shimmering columns of gas. The water temperature above the summit has risen by nearly 2 degrees Celsius, and sonar imaging reveals expanding cracks around the rim, cracks that weren't there just months ago.
If magma continues to rise at its current pace, the next eruption could happen not in years, but in months. And while it won't breach the surface, scientists warn it could unleash underwater shockwaves powerful enough to alter ocean currents, destroy ecosystems, and trigger tsunamis if the pressure releases too suddenly. So the terrifying question now echoing through research vessels across the Pacific is this: if Axial Seamount is the most active volcano in the Pacific Northwest, what happens when it finally wakes up again?
Chapter 2: The Magma Pulse, the volcano that breathes beneath the sea. What if the most active volcano on America's west coast wasn't on land, but hidden, alive, and pulsing under thousands of feet of seawater? At nearly 5,000 feet below the surface, Axial Seamount is showing signs that it's not sleeping at all, it's breathing. Satellite radar and seabed pressure sensors have revealed a repeating pattern. Every few weeks, the seafloor inflates, then subtly deflates, as if the volcano were inhaling and exhaling magma through its veins. Scientists call it a magma pulse, and it's unlike anything else recorded along the Pacific seafloor. Instruments from NOAA's Nemo Observatory show that the caldera's floor has been rising steadily, over 25 centimeters since its last eruption. That might sound small, but on a geological scale, it's enormous. It means magma is pushing upward, cracking open the crust, and building pressure at a rate faster than any previous cycle. Deep-sea drones patrolling the caldera rim have captured footage of new fissures glowing faintly orange, releasing superheated plumes that twist through the dark like underwater lightning. The temperature spikes are extreme, up to 410 degrees Celsius, enough to boil water instantly, if not for the crushing pressure of the deep.
And here's the part that has researchers alarmed. Axial's pulses are beginning to sync with tidal cycles. During low tides, when pressure on the crust drops, the volcano quakes more frequently, a dangerous feedback loop that could one day trigger an eruption at the exact moment Earth's gravitational forces align. If Axial blows again, the eruption won't be quiet. The 2015 event unleashed enough lava to cover Manhattan 10 times over, spreading molten rock across an area the size of Seattle. The next one could release even more energy, and scientists say it's not a question of if, but when. So the chilling question remains: if this volcano's heartbeat is growing stronger, how long before it erupts, and how far will its pulse reach? Such as the seafloor is rising, the Pacific ridge begins to fracture. Chapter 3. The seafloor is rising, the Pacific ridge begins to fracture. It's hard to believe, but satellite altimetry and deep-sea sonar now confirm that the Pacific seafloor itself is rising. Around Axial Seamount, a dome-shaped bulge has been detected expanding outward, a slow-motion swell of molten rock pushing the crust from below. Over the past few months, oceanographers from the University of Washington and NOAA have watched the surrounding ridge inflate like a balloon. The ground deformation is not uniform. It's fracturing, splitting open in jagged lines that stretch for miles along the Juan de Fuca ridge. Each crack acts like a pressure valve, releasing gas and magma in bursts that light up seismographs in rhythmic waves. Remote sensors deployed by the Ocean Observatory's initiative have recorded over 60,000 microquakes in the past 6 months alone, the highest activity since the 2015 eruption. Some quakes are so shallow that researchers believe magma has already reached within a few hundred meters of the surface. Sonar scans taken last week revealed new vent fields opening at the ridge's northern flank, glowing plumes of hydrothermal fluids rich in iron, sulfur, and methane. The water above them shimmers like heat over asphalt, and marine life that once thrived in the area has vanished. Scientists say this combination, swelling crust, vent expansion, and ecosystem collapse, is the same chain of events that precedes every major submarine eruption. Even the ocean's chemistry is changing. Instruments have detected rising concentrations of hydrogen sulfide and carbon dioxide across a 20-mile radius, gases that can acidify seawater and suffocate marine organisms. In the most affected zones, oxygen levels are plummeting, and the deep ocean currents that flow past Oregon's coast are carrying traces of this chemical signature toward the continental shelf. What frightens researchers most is not what's visible, but what's hidden. Beneath the ridge lies a magma reservoir nearly 5 miles wide, and models suggest it's expanding faster than expected. If that chamber breaches, the result could be an underwater blast equivalent to a volcanic eruption 10 times stronger than 2015. So the question isn't whether the seafloor will rise, it's how much more it can stretch before it finally tears open. If the ocean floor itself begins to split, could the Pacific send its shock all the way to our shores? Chapter 4. The ocean that burns, superheated vents ignite beneath the waves. What if the ocean itself could catch fire? Just west of Axial Seamount, explorers have discovered plumes of boiling water,
each one shooting hundreds of feet into the dark. Bursts of heat so intense that they've begun melting the seafloor around them. These aren't ordinary hydrothermal vents. They're something entirely new. NOAA submersible ROV Jason 2 recorded columns of supercritical fluid, water so hot and pressurized that it behaves like both a gas and a liquid at once.
Temperatures inside these plumes exceed 720 degrees Fahrenheit, 380 degrees Celsius.
At those extremes, metals dissolve like sugar, rocks turn soft, and the chemical reactions generate electric currents strong enough to distort sensors. The ocean here is no longer just a body of water. It's a conductive network of minerals, heat, and gas, reacting like a living machine. Scientists call this phenomenon hydrothermal ignition, when magma rises so close to the seabed that its heat transforms seawater into an electrical plasma. And Axial Seamount is now the hottest known point on the entire Juan de Fuca Ridge. The consequences are as strange as they are alarming. Deep-sea cameras have captured fields of glowing rock, their surfaces shimmering blue like liquid lightning. In one section of the ridge, lava tubes have fused into transparent glass, reflecting the faint glow of magma moving beneath. And when methane gas escapes into these zones, it combusts, creating brief flashes of flame that flicker in the depths like lightning trapped under the sea. Marine biologists studying the area are stunned. The normally thriving hydrothermal ecosystem, teeming with tube worms, blind shrimp, and extremophile microbes, is collapsing. Entire colonies have died off, replaced by patches of blackened sediment and clouds of suspended sulfur crystals. The local chemistry has shifted so violently that even robotic sensors are corroding mid-mission. Experts warn that this rapid thermal escalation could signal an eruption countdown, the final stage before the magma chamber ruptures. The last time Axial behaved like this, the 2015 eruption followed within weeks. So the haunting question now echoing through NOAA's research ships is this: if the ocean floor is already boiling, what happens when the crust finally breaks? Chapter 5. The magnetic surge. Earth's energy field is warping above Axial Seamount. It's hard to believe, but satellites orbiting hundreds of miles above the Pacific Ocean have begun detecting magnetic distortions directly over Axial Seamount. At first, the readings seemed like sensor noise, faint waves pulsing through the magnetosphere every 20 minutes. But after cross-checking with NOAA's underwater observatories, scientists realized something extraordinary. The magnetic field was pulsing in perfect rhythm with the volcano's seismic tremors. That discovery changed everything. Axial Seamount sits not only on a spreading ridge, but also atop a magnetic anomaly, a region of the seafloor rich in iron, nickel, and other conductive minerals. As magma surges through these rocks, it generates electric currents, creating a phenomenon known as geomagnetic induction. Normally, these signals are faint, but lately, they've become so powerful that they're rippling through the ionosphere, distorting satellite navigation, radio communications, and even atmospheric plasma layers above the Pacific Northwest. In simple terms, the volcano's heartbeat is now echoing into space. When the magnetic field wavers, so does the ocean around it. Researchers aboard the RV Thompson recently recorded fluctuating electromagnetic currents running through the surrounding water, enough to interfere with instruments and drones. One submersible even lost navigation for several minutes when it passed through a plume of magnetically charged fluid rising from the vent field. The implications are staggering. This kind of synchronization between deep Earth magnetism and upper atmospheric distortion has never been observed before. Some scientists suspect that the magma chamber has become electrically active, possibly ionized by rising pressure and metallic fluids. If true, Axial may not just be a volcano. It's acting like a planetary generator, briefly linking Earth's magnetic and geological systems into one. Chapter 6. The Tremor Storm. Axial's quakes multiply into a relentless roar. What if the ocean floor wasn't trembling, but screaming? For months, Axial Seamount has been whispering warnings. Small quakes, heat pulses, and the faint rhythm of magma on the move. But now, those whispers have become a storm. Since early spring, seismographs anchored across the Wanda Fuca Ridge have recorded an explosion of seismic activity. Not dozens, not hundreds, but tens of thousands of quakes in rapid succession. Scientists call it a tremor storm, a sustained barrage of low-magnitude quakes so constant that they merge into a single vibration, like the hum of an approaching engine. The source? Deep beneath Axial's central caldera, where molten rock is forcing its way upward through brittle crust, cracking stone in every direction. Now, as real-time monitoring systems have gone into high alert, the tremors are now so frequent that they've overloaded some of the ocean observatory cables connecting instruments to the shore. It's like the seafloor is breathing in fast motion, said Dr. Lila Donnelly, a volcanologist stationed on the RV Atlantis. We're watching the magma fight its way out. And it's not just noise. The quakes are getting shallower. Over the last 2 months, seismic models have shown the focal points rising from 3 kilometers deep to just under 800 meters. That's dangerously close to the seafloor. If this trend continues, an eruption could occur without warning, cracking open new vents and releasing massive flows of lava across the ocean bottom. The soundscape tells its own terrifying story. Hydrophones, underwater microphones, have recorded subsonic booms reverberating through the water column. The audio doesn't sound like explosions. It sounds like rolling thunder, constant and low, spreading outward for hundreds of miles. The ocean itself has become a resonating chamber for Axial's fury.
Chapter 7.
It's hard to believe, but new sonar scans have revealed something rising from the seafloor near Axial Seamount, a massive dome of molten rock, expanding silently beneath miles of ocean. At first, researchers thought it was an imaging glitch, a sonar echo distorted by dense water layers. But as the readings were repeated week after week, the truth became undeniable. A bulge, nearly 3 miles wide and over 300 feet tall, is forming directly under the volcano's caldera. It's the most rapid inflation scientists have ever recorded in a submarine volcano. According to the Ocean Observatory's initiative, the magma chamber beneath Axial is now pressurized beyond pre-eruption levels seen in 2015, and it's still rising. The dome is pushing upward, bending the seafloor like a drumskin stretched to the edge of rupture. Each pulse adds more stress to the surrounding rock, and each microquake releases only a fraction of the growing tension. Deep-sea drones deployed last month recorded eerie signs around the base of the bulge. Shimmering heat waves, metallic dust swirling in the water, and fissures exhaling bubbles of carbon dioxide and sulfur. Some vents glow faintly red at night, the unmistakable sign that magma is just below the surface. And now, the deformation has spread beyond the volcano. GPS buoys floating above the site are drifting apart, indicating the seafloor is warping laterally, stretching outwards as if the crust itself is trying to breathe. Scientists have even begun to detect slow tremors along the ridge flanks, suggesting magma may be infiltrating new cracks, extending the volcanic network in all directions. Experts warn that if the dome keeps growing, it could trigger a caldera collapse, when the chamber empties violently, causing the entire summit to cave in. In a land volcano, that would send pyroclastic flows racing down the slopes. Underwater, it would displace massive amounts of seawater, unleashing tsunamis that could reach the Oregon coast within an hour.
Chapter 8. The breaking point, when the Pacific decides to breathe fire.
It's almost impossible to believe, but the quiet depths off Oregon's coast may soon become the stage for one of the most dramatic geological events in modern history. For years, scientists have watched Axial Seamount swell, tremble, and hum beneath the surface, a sleeping titan whose heartbeat now grows louder with each passing day. The ocean above it remains calm, deceptively serene, but the instruments anchored below tell a very different story. The pressure dome is expanding faster than ever. Vent temperatures are spiking, and seismic pulses are now so strong they're detectable on land. The Pacific, it seems, is preparing to breathe fire. But here's the part no one expected. Electromagnetic readings indicate that Axial's magnetic surge is syncing with neighboring volcanic systems, Mount Meager, Mount Rainier, even Mount Hood, all showing subtle seismic echoes of Axial's heartbeat. It's as if the entire Pacific Northwest is resonating, connected by hidden veins of molten rock that stretch from the ocean floor to the continental crust. For oceanographers, this isn't just a volcanic event. It's a continental warning, proof that the same forces shaping the deep sea are tugging at the roots of the land itself. The line between the Cascadia subduction zone and Axial's volcanic ridge is blurring, and if either one gives way, the other could follow. And yet, amid all the dread, one truth stands out. This is Earth, alive and evolving before our eyes. What we're witnessing at Axial isn't just destruction, it's creation. New crust, new heat, new life. The endless rebirth of a planet that refuses to stay still. So the haunting question remains, if the Pacific has finally decided to rise, how long before the rest of the Ring of Fire answers back? If this story left you questioning what lies beneath our oceans, don't look away now. Subscribe, turn on notifications, and join us as we uncover the next awakening beneath the Pacific. Because the Earth isn't silent, it's speaking. And the next eruption might be closer than you think.